Good evening, I am Mr. Ish. You're looking here at a video that's more about your regular classes versus standardized test preparation. We're looking here at simple geometry proofs, two of those, and I am Mr. Ish. Thank you for joining me for this video. The purpose of this first question is to help you handle a very simple proof and give you the confidence you need so you don't get intimidated by questions such as this. The first question is this: show that angles A and B are supplementary angles if lines A and B are parallel to one another. We have two lines that are parallel to one another. They are cut by this transversal line which generates this angle A and this angle B. How can we go about proving that both angles A and B are supplementary, meaning A plus B will equal 180 degrees? It seems rather easy and intuitive, but we can do this in a good manner. If you are looking at this representation, and I'll blow it up for you right here, we have something which looks like this. Here's my angle A, here's my angle B. By means of the opposite and corresponding angles which are generated when a parallel line is intersected or cut by a transversal line, if you look at just this part right over here, this angle B is the same as angle B forming right over here. So now you know that A and B are involved here in terms of a straight line. When you're looking at this representation here, A and B, if you want to express one in terms of the other, you know A and B must be involved with a straight line, therefore they must add up to 180. If you express one in terms of the other, if this is B and that's A, you can also say this right over here is 180 minus B. Then logically what you're stating over here is you've done a little bit of a substitution. You've logically stated that A is equal to 180 minus B. That's what we've stated right here with this expression over here. Because we know B was just an angle B, then A must be 180 minus B. This way we've converted everything over here in this rectangular box into one variable, B's. A has been expressed in terms of B. When you've done expression of A in terms of B, all you have to do is take B onto the other side and you get A plus B is equal to 180, and there it is. Right there you show that A and B are supplementary angles, and that very well denotes these two, A and B. And anywhere in this diagram right here, wherever you can do an A and a B representation, they'll always be by their sum equal to 180 degrees, and this question has been done. For the second question of this video, which is also our last question, we have a very interesting concept over here. Something which is frequently never taught to students. We have to show that the area of a triangle is also equal to half AB sine theta. We're frequently taught this formula, and this other one is never taught. But this right here is a very legitimate formula for the area of a triangle, and we have to show that this is equal to that. If you have a triangle which looks something like this, a representation of a triangle, you draw a line over here and you make a right angle over here. So you've created two separate right triangles within this main triangle. We have something over here which is the entire base of the triangle. We have a certain height. We can call this A, and we can call this angle theta. How can we derive this formula using that representation? How about if we know the area of a triangle is half base times height, which we've written over here, and we know height. How can we calculate height using angles over here and using trigonometric functions? What if we did sine theta is equal to opposite over hypotenuse? Opposite over hypotenuse, and we solve for that opposite side, which happens to be the height. H is equal to A sine theta. This right here can represent and substitute for this H over here. So you get half B A sine theta, and you can rewrite this as half A B sine theta, because order does not matter when you're doing a product of variables. This thing is the same as that. And this right here is what we were trying to show. So half base times height for a triangle is the same thing as half AB sine theta. And this is a useful formula for you to remember. And you might see it sometime. And with that, we end this video. Thank you for watching this simple geometry proofs video. Have a good day.